Hello, this is Loy Sneary with Gulf Coast Green Energy here in Texas, just south of Houston. We are the representative for the Electrotherm waste heat to power generator. Electrotherm is part of the Bitzer Group. Just to let you know, Bitzer is a global company. In fact, they're the largest manufacturer of screw compressors in the world. But what I'm here to talk to you about today are new efficiencies from waste heat for industry. I appreciate the opportunity to be here, and I want to go over three of the solutions that we've developed that turn waste heat that would otherwise be vented to the atmosphere and turned into electricity. First, just a little bit about waste heat. There's actually over 15,000 megawatts of opportunity in the world for making power from waste heat. We see that as a huge market, and it's why we developed the solutions that we have that convert that heat into a beneficial use, and that's for power that can be used on site or sold to the grid. Just real quickly how it works, and if you can see my cursor here, this is kind of a schematic of how it works. So we use a liquid heat, and so the heat enters into a heat exchanger where the heat is transferred to a refrigerant. The refrigerant boils at about 56 degrees, and so from there on, it's basically the same principle as a steam turbine or a steam Rankine cycle. And so the refrigerant is boiled and vaporized. That high pressure vapor is what actually turns our expander, and which is connected to the generator. The refrigerant then is turned back into a liquid in our condenser, and it stays in a closed loop in the system. So again, we make fuel and emission-free power from waste heat. These are some of the projects that we've done and projects that we've worked on. We've done several solar thermal projects where the solar thermal arrays are providing the hot water or hot fluids for us. In fact, our furthest project that we've done was on the island of Cyprus for Middle Eastern Technical University. A big market for us is reciprocating engines, and that's what this is. This is a gas compressor unit, reciprocating engine. These are the compressors. This is the radiator that cools the engine and the compressed gas. So again, internal combustion engines is a big market for us. Compressed gas cooling is also a big market. We've worked on several projects where we actually take the heat from compression, turn that into electricity, and reduce the heat of the compression and save the electricity that would be required to cool that compressed gas. I'm going to talk also about co-produced water or any kind of hot liquid that needs to be cooled. I'll show you an oil and gas application, and then I'll discuss our flare gas to power project that we've done, where we actually make a beneficial use of the flare gas. So starting off with our radiator replacement solution for internal combustion engines. The U.S. Department of Defense came to us and said, we kind of like your technology, but we want to see if you can develop a system that will reduce fuel for us. And as you probably know, the Department of Defense is the country's largest consumer of fuels. And so it's very important to them. And so we developed this, and we call it the radiator replacement. I'll show you that this box right here, this gray box, there's a Cummins 2,000 horsepower engine inside that container. You can't see it, but there's no radiator there because our waste heat to power generator, again, we take the heat. In this case, we take the heat from the jacket water. It's the water that cools the engine. We plumb that over to our equipment. We make power from it, and then there's no need for the radiator in there. We also, in this case, used exhaust gas heat to make additional power. And so the results of that were verified by Southern Research was that it is a complete engine radiator replacement, and we can reduce the fuel consumption or actually add more power to the engine, either way you look at it, by 10 to 12%. The neat thing about it is it's easily transportable. This unit here can be picked up with a fairly good sized forklift off a truck and set down. It can all be in operation in less than 12 hours. Payback on it's between 2 and 3 years. This is just kind of gives you an idea of the connections. It's an easy retrofit. If it's a new engine, it's very easy. But we retrofitted this engine out in the field. These are our guys here, and you can see they're just rerouting the jacket water connection right here. We plumbed it and came down to the side with these quick connects, and then we just use flex hose to go to our ORC, our waste heat power generator. Also want to tell you about the use of the beneficial use that we can make of flare gas. So this was actually done on a Hess well pad up in North Dakota. And so the Houston Advanced Research Center came to us and said, can you develop a solution to reduce the amount of flare gas that's happening in all the shale plays? And we said, yeah, let's see what we can do. And this was our project, and it was a fairly simple project. So we take the flare gas, run it through a low emissions boiler, which gives us the hot water that we need to generate our power. It was a very successful project. We also had Texas A&M there on site to measure the emissions reductions. We knew there would be emissions reductions, but we couldn't determine how much that would be, but A&M did. And so you can see down here, CO was reduced by 89%, NOx by 48%, and VOCs by 93%. The neat thing about this works anywhere where there's a flare. So not only oil and gas, but wastewater treatment facilities that may be flaring their methane, or landfills that are required to capture and dispose of their methane. I mentioned that we have done a project, and we do projects for produced water. This is a project that we did in Mississippi for an oil company, and it's a fairly simple. And so the hot water that comes up with oil and gas production is separated over here in the separator. It's called the knockout tank sometimes. And we just put a three-way valve in there, and so we sent the hot water out of the separator up here into flex tubing over here to our ORC. We generated power from that hot water. We took heat out of the hot water. We utilized that heat to make power, and then we sent it back down in the other pipe to the injection well where it had been going all along. Neat thing about that, we delivered this equipment on a drop deck trailer. We dialed it down to 7 o'clock in the morning, and we were making power by 3 o'clock in the afternoon. So again, this was an oil field application, but for industry, anywhere where you have processed fluids that need to be cooled, rather than paying electricity to cool them, we can use that heat to generate power and reduce the cooling load at the plant. So it's kind of like a twofer. We can make power that can be consumed on site, and we reduce the amount of power that it takes to cool those fluids. So some of us have been keeping an eye, obviously, on regulations. There's quite a big controversy on whether the climate is changing or not, but we view it this way. Whether there's regulations or whether there's truth in the climate changing or not, the reality of it is that business values are changing, and they're being changed by the marketplace. Many of us know of BlackRock. BlackRock is the world's largest funds investment manager. And this is just an excerpt from Larry Fink, who's the chairman and CEO of BlackRock. And you can see there that BlackRock voted against or withheld from 4,800 directors at 2,700 different companies. And those were companies that were not making sufficient progress on sustainability and related disclosures and the business practices and plans that underlie them. So what I'm saying is that we're all here to look for efficiencies and best practices and sustainability, and that is being driven not necessarily so much by government regulations, but by the market and the people who invest in our companies. So again, thank you for your time, and I appreciate the opportunity to be here. I've saved a little extra time in my presentation to add to the question and answer part. So I'll be looking forward to those questions and answers, and thank you again.